Sleepy time space offers a soft hello, a slow invitation to look up and feel small beneath a sky that yawns wider than memory. Begin by picturing a star, not a point of flash, but a patient furnace of hydrogen and helium, where atoms fuse quietly in a core so dense and hot that time itself seems to breathe differently. That fusion is not a single bright burst, but an ongoing, measured flow of energy, heat, and light leaking outward like a long, steady exhale. Imagine that exhale as a mellow pulse. Stars wear color as a gentle thermometer. The hottest ones shimmer in blue-white tones, while cooler stars glow with a softer, red tint. Let your thoughts trace those hues across a slow-moving tapestry. Blue pinpricks here, red smudges there. Galaxies scatter like distant embers. Think of the Milky Way as a great spinning disk of such embers, a broad, thin river of stars arcing across the night. Each individual light belongs to a vast community which drifts and sways over timescales so long they become. Turn the mind to planets next, orbiting their parent stars with firm, unhurried steps. Some are small and rocky, others bloated with gas. Some hug their stars so closely that one side bakes in perpetual daylight, while the opposite side sleeps in eternal night. Picture the winds on such a tidally locked world, fierce, moving heat from the day side to the night, setting up a vast, slow respiration across the planet's face. Picture another planet far from its star, cold and still, with an atmosphere so thin. Now, imagine clouds that are not water, but metal vapor or mineral dust, glittering like faint, impossible rain. On some worlds, temperatures are so extreme that rocks evaporate into gaseous veils. Those vapors condense into droplets of exotic composition, drifting along in measured, dreamlike currents. The process repeats itself. Heat lifts particles. They mingle and condense. They fall. Let that repetition settle over you as a slow, patterned hum. Smaller phenomena deserve attention too. The whisper of a stellar wind pushing through space, the invisible cocoon of a planet's magnetic field, the way a tiny dust grain catches light and makes the dark seem textured. All of these layer upon one another, building a sprawling, low-frequency symphony. Don't try to grasp everything at once. Instead, let individual images, a glowing spectrum, the ancient wobble of a galaxy, a planet's endless dusk, arrive and pass like gentle waves in this quiet accumulatio, softly, indefinitely, without ending, like a lullaby. Sleepy time-space moves onward in a whisper, guiding you into the slow, patient work of light. Picture the James Webb Space Telescope, a golden segmented mirror open like a quiet blossom, instruments chilled so that faint infrared murmurs can be heard. Webb's core gift is gentle and exact. It takes light that has drifted across time and stretches it into a spectrum, a long ribbon of shade and hue. That act, spectroscopy, reads the fingerprints left by atoms and molecules. Think of starlight as writing on a pale page. As it travels through gas or a planetary atmosphere, certain wavelengths are swallowed, leaving slender gaps. When Webb disperses the light, those gaps appear as dark lines. Each line names a substance: water vapor, methane, carbon dioxide, metal oxides, revealing chemistry. Like soft, repeating motifs, allow each motif to sound in your mind as a low bell, regular and calming. Its repetition forming a slow, lulling tune. Webb listens mostly in the infrared, where cooler objects glow and dusty nurseries become visible. In those wavelengths, telescopes see through curtains of dust, exposing warm cores where stars and planets are born. Imagine a dense cloud where embers of formation pulse. Webb's instruments trace those pulses and record subtle spectral changes that hint at motion, temperature, and composition. Those changes are gradual, like tides moving under a moonless sky. When Webb studies an exoplanet, spectra can suggest winds and contrasts between day and night. A tidally locked planet may present different faces of chemistry. As it orbits, each face a new phrase in an ongoing lullaby. Picture a slowly turning carousel where light shifts in tone. Webb listens to each turn and notes the gentle variation. The result is never hurried, just steady evolution, a patient unfolding of information. Spectroscopy can also point to clouds made of minerals or molten droplets, rain that is not water but crystals or metal. Such atmospheres imprint unusual absorption shapes, and decoding them feels like learning a new, exotic lullaby's cadence. Laboratory spectra act as keys. By matching details, scientists translate unfamiliar notches into named materials and imagine weather unlike anything on Earth. Because light takes time to travel, Webb sometimes delivers images and spectra from long ago. Each spectral line becomes a sentence written in the past: the birth of a star, the cooling of a planet, the slow enrichment of an atmosphere over eons. These are narratives told in small, repeating sounds. The kind of stories that can be listened to and drifted through, rather than rushed. In sleepy time-space, let these spectral motifs become a soft, repetitive music. Hear the dark lines once, then again. Let their order and spacing rock the mind. The James Webb Telescope spreads light into a patient manuscript, and our role is gentle, to trace those lines, absorb their quiet patterns, and let the slow recital continue into the next movement. Let each measured breath of spectral data lengthen and keep a space open for the slow arrival of further luminous details.